So this was yesterday's yesterday's application. We have started working with object-oriented programming. So in which we created one point class, then we extended point to a new class called as point 3D. We created a point 3D class here. So from the existing point class we created here point 3D class. We extended to point 3D here. So this is nothing but inheritance. Existing classes features we are using with the point 3D class. So without redefining the features of point, so whatever we had in the 2D point we have taken and put into point 3D. This is in fact inheritance and it comes under classification hierarchy. Okay, even yesterday we saw how to upcast an object and how to downcast also an object. How to upcast we have seen, how to downcast also we could see. Now here, object p dot to find length between points, this needs actually just a point object, but I am passing here point 3D object. So automatically it is upcasted. So downcasting by default is not allowed. Here forcefully I am downcasting it, but this is what exactly upcasting. I have upcasted the point 3D object to point. So like this here we use even features like upcasting as well as downcasting. Point 3D is what? It's a new class. It's a new class from the existing class we created. We declared here one enum, enumeration, its quadrant that can be giving us a first, second, third and fourth quadrants. Similarly, when we look at the point class, here there are two private data, it's nothing but fields we say, then we have two constructors, then we have setx, getx methods, setY, getY methods, and a method we have here with the help of that we can move a point from one location to another location. We have a get quadrant method, with the help of that we can be returning the quadrant of the given, in what quadrant exactly point is lying, we find with that. Then here we have overridden. This feature is called as overriding. With the object class already toString is available, we have overridden here the method which is part of the object class. Okay, then I have written here two different methods. In fact, three methods I have written. So the two method, I think, okay, find length between 2 points I have written, int x, int y. One more thing is here what? Find length between 2 points, point P. In the first case I am passing xy coordinates, in the next case I am passing just point object. And this is also nothing but overloading. Just like constructors, here we have overloaded the methods. We have overloaded the methods. The method name is what here? Find length between 2 points. We have given here x coordinate, y coordinate. Similarly, with the next method also, the method name is same, but just we change the parameter here. In the first case, we pass two parameters, x coordinate, y coordinate. In the next case, we passed a point object as parameter. So like this, we have overloaded the methods. This feature is called as method overloading. This is part of the polymorphism. So this is nothing but part of the polymorphism, and this is called as here compile time polymorphism. This gives us early binding as well as compile time binding. This is giving us early binding or compile time binding, whereas the overridden concept gives us, toString gives us a concept called lazy binding, late binding or runtime binding, we say that. When you override, the concept is basically here lazy binding or late binding. But when you take the overloading concept, that is nothing but early binding, static binding or compile time binding also, we say it. So we have written here two methods. Find length between 2 points. We passed x and y coordinate. With that we try to find out the distance between the 2 points. Similarly, one more method we have written, find slope between 2 points. Int x, int y. Then we try to convert into degrees. Y minus yc divided by x minus xc. That's nothing but m. We are getting m there. So 1.0 star, that is m. With that we find the slope of the given line. Given line slope, we are going to find out. So this can give some degrees there. It's going to give degrees like that. We can calculate here the given, the given slope or angle of the given line. So we try to find out this way. This may be correct or not. You need to think about it. Find slope of 5 points. Okay, so like this, we have written a new method called as find slope between 2 points, and this method is going to give us angle of the line. Then here we have written another class called as point 3D, which is extending here point class. The features of point, they are going to be available in the point 3D. Then in this, we have defined just one more field called as ZC. ZC is nothing but Z coordinate. It's a another coordinate we are adding here to the same point class. So whatever features you have in the point, they come into the point 3D. Then here we have constructors, three constructors we gave there. One is default constructor. We can call here super constructor. That means the base class constructor we call with the help of the super. Now similarly, here what we do, public point 3D, int x, int y, int z, super xy we have taken, zc equal to z we have taken like this. So here we call the super class constructor with the help of the xy. Then we write here zc equal to z. Like this also we can call here. In the third case, we write like this, public point 3D, point p int z. So point p we have taken. Then other thing is what here, z coordinate also we are using. Like this we have created here a new class called as point 3D class. So this way I have taken a new class called as point 3D class, and here toString method is overridden again. Here we have overridden the toString method. All the overridden methods are shown with the up arrow here. Overrides point.toString. In the point class we have toString method that we are overriding here. So this is exactly what it is, a inheritance. It is nothing but single inheritance. If you take point 3D, it is inheriting from just a point class. From point class it's inheriting, and you have point features within the point 3D. Now let us come to one more class. This time we create a final of it. So further that cannot be overloaded. If you try to overload further, it cannot be, further if you try to inherit, it will not be inherited. So like that we try to write a final class. In fact, we use final keyword. We have a final keyword we can use for final variables. For final variables we can use. That means final variables are going to behave like constants. So once you declare a variable as final, you cannot modify the contents of them. Similarly, final methods. Whatever method you mark as final cannot be overridden. You cannot override the method if you mark it as final. Similarly, final class, this cannot be inherited. We use final keyword with the variables, with the methods, with the class. Similarly, one more we use finally. Final is different, final is different. Finally, we use with the try-catch blocks. Okay, finally we use with the try-catch blocks. Whenever you have any kind of resource leaks at that time, with the help of finally block, you can be handling them. So resource leak meaning is you create a file object. So when you create a file object, okay, so due to some reason you forgot to close the resource. So in such cases, what happens? The resource is open, others cannot use. So such problems you can overcome with the help of the finally block. With try-catch block, whatever code you write, if it is using any file, so in that finally block you can handle it, you can close the file properly because they are resources. So to handle resources we can use the finally block. Final is a keyword, finally is also a keyword. Final we use with variables, with methods, or with the classes. But as far as finally is concerned, finally cannot be, finally can be written only with the try-catch blocks. We can use with the try-catch and finally. So when you handle files at the time, you require finally block. So let us try to use here a final variable. So here what I do, At what time exactly the object is created, I want to handle it. So therefore, in the point clause itself, I can define it. So put something like this: creation date followed by this is creation date time. Like this, I can put it. Create date, creation date time. I can make this way here. So this is going to be date, creation date time. You put this as here final. Final put this equal to here. Try to write. This is here new date. Later on, if you try to modify, this can't be modified here. Okay. So here therefore what is required for this is, on the top you must be adding import java.util.star. You can put like this java.util.star. So what is available? Therefore here we created a final, this is final variable we created, final date, creation date time equal to new date. So when point object is created at that time, this will be available for us. This is going to be available for us. Then try to define here a method. We define here a method. Here write public followed by, we can get here the date and time. We can write like this: public date get point creation date time. Like this we write it, and inside this we can be just returning return. So what do we return here? This is going to be return here, whatever variable name it is, we take it and we try to do this. Come to this point and try to set here. This way we can return this. We are going to be returning this particular thing here, and you can mark this as here final. We put here public final. We can mark even this one as a point creation date and time. So this cannot be overridden. If you try to override, if you don't want to use, don't use, that's all. If you don't want to use, you can just leave it like that. See, superclass functionality you have always in the child class. Okay, but what happens sometimes, you can create a superclass object and you refer the child class. In such cases what happens, whatever methods you have in the superclass, you can invoke them, and child class methods we need not, it's not going to expose those methods. So you create a superclass object, then try to refer the child class with that. In such cases what happens, whatever methods are available in superclass, you can access them, you can leave the child class methods. So this is going to be base, superclass is going to be base. So without base, the extended part you cannot use, but if you want to use only base part, just you can use the base part using the base class reference variable, and you can refer the child class object with the help of the base class reference variable. In such cases you can avoid child class methods. So I'll demonstrate that. Now first of all, here we have written a new method called as public final date get point creation date time. So with this what happens here, you can use the method in the child class, but you cannot override it. If you try to override, this cannot allow us to override. Here we have defined two things. One is what public, this is here, we have written it as final. This is written as here final date creation date time equal to new date. This is exactly what it's returning date time object. Similarly, we have written a method here. The method is what? Public final date get point creation date time. We have written like this. With the help of this, you can just get the creation date and time. With every class, we need not write this, because creation time whether it's point 3D or point class or point color, color point, whatever it may be, we need not define every time this one. Whatever features you need to change with the child class, in such case only you should write your own methods, you should overwrite. If you don't require any data modifications or any data changes, there is no point in overriding the methods. So therefore, here it's not required. It's not required. Therefore, I have made this as a final method. It's nothing but final method. In the child class, if you override, this gives error. So let me try to write here I come to the point 3D, then I try to override this. The method name is what for us here? The method name is going to be here. This is the method name. Just try to override again this one. What happens? Let us see in this. Will it allow us or not to override? Just come to this point and here trying to override this. But this is nothing but it's a point method only. Try to come to point 3D. The point 3D, try to override that. It will not be overridden, but just try to override that particular thing. Okay. So here I am returning this. Return followed by, I can write this as here, return super dot, I can get here, get creation date time. Okay, so in such cases it does not allow us to overwrite. Reason here, if you come to this point, it says cannot override the final method from point, because there is no difference, because we are calling here just superclass method only. Super dot get point creation date and time, since we are invoking, so explicitly we did not override. If you try to override the final method, it will not allow to override. So therefore, there is no point in overriding this particular thing here. It's nothing but error, so you can't do this. Therefore, I comment this point here. That means what, a final method cannot be overridden. A final field cannot be modified. I take here, try to write here a set also. For which one? For this particular point, I have here final date, creation date time. I try to modify this. Here write public followed by void set creation date time. Let me put like this, and inside this try to assign the data. Creation date time equal to, try to put here new date. If we try to write like this, it will give definitely error for us. Move cursor over this point, it says the final field point creation date time cannot be assigned, because this is a final field. So final fields cannot be modified there. If you try to modify, it gives error. But you can use here just a get method. With the help of get method, existing value can be retrieved there. So you can retrieve the existing value of it, but you cannot set a value for that. So assigning is actually not allowed in the case of final field, but whereas you can retrieve data from the help of the get point creation date time. So therefore, here we use a final keyword to make a variable as constant. Similarly, a final method also we can declare. That method cannot be overridden in the child class. Take child class, in that it can't be overridden, because we have defined it as a final method. Public final date get point creation date time. If you try to override, it gives error. So it does not allow overriding the final method there. Similarly, we have one more class called as here, one more type of class we can create. The class can be called as here color point. So I try to make like this, public, then followed by here final, try to write like this, final, this is class, then here it is color point, I try to put here, so color point, then here I write extends just point, like this I try to set it. Since this is public, you cannot put there. Okay, here you can write like this. Final class color point extends point. Like this we are taking it. So here extra feature what we add is just color only. We are going to be adding in this. For adding color, we can just add on the top here import java.awt.star I put here. AWT is a framework, abstract windowing toolkit. Their color object is available for us. Let us try to use a color object here. So let's come second time. Fine. Here I declare a final class, which is here color point, which is extending the point class. Here extra one feature I require. That feature is going to be just color. Color is available here for us. Put color. See, p color point color is equal to color dot. Enumeration is available. You can assign some kind of color in this. You can assign some color. I can use it as a green color. I can assign right now a green color in this. I created a green color in this. Then followed by I should call the constructor. I am going to call constructor, and here I use this constructor, superclass constructor called like this. So here public followed by I put only here color point I put like this, and here inside this I can be invoking I can call here this constructor. So this followed by 0, 0, I can invoke like this. Okay, fine. Not this. I can invoke here superclass. Okay. Superclass constructor I can invoke like this, followed by 0, 0 like this. We can invoke this. It is invoking actually a superclass constructor for us here. We are invoking just superclass constructor. It is going to pass 0, 0 there in such cases. Superclass constructor we call like this, color point here. So it's invoking in such cases the superclass constructor. it's passing just 0 0. And similarly, we require one extra feature also in this. Color already we set there, but next time we can put like this here, public followed by color point. Next in this we can write it as super 0 0 is not required at all, just super when you call automatically it calls. Okay, followed by this one int x, int y, then other thing here it is we use as color also we can use. Default color can be assumed, color is not required. So here in such case we can take it like just super followed by x comma y we can use. Like this we can be invoking it. In the same manner it is public, then color point. This time we put int x, int y followed by even color CLR. You can put color object, you can take, we set that color here. So this is super, again x comma y we take. The next one must be in this dot color, point color, we can set it as here CLR. We can assign like this CLR. A color object can be assigned this way here. So sometimes what happens, it may be passing only color object. Public, then followed by here color point, followed by only we pass color. So in such cases we invoke the super class here. Just we invoke super class, followed by here you can set this dot point color, this equal to CLR you can set. So in this manner we can be creating a new class called as color point. We created color point. Extra method what we add in this is some extra method. You can just write get color. Write here public, then followed by color. Write it get color. So this can be returning for us here the color, whatever color it is, it can return. Return here this dot here point color. We can specify like this. We return here color of the point. Similarly, we can set a new color. Public void it is. Then write here set color. So here again we need to pass the color object CLR. This can assign here value for us. Write it this dot point color, this equal to CLR you can set. So this way we created a new class. We have created a new class here. We created here color point. Okay. Now if you try to create one more class out of this, just try to write here class extra point, something like this. Let us try to create here extends color point. What happens, see in this color point, then as soon as you put that it gives error for us here. Look at this, it says the type extra point cannot subclass the final class color point. So if you try to extend the color point to some new class, it will not allow the creation of new class. It can't be extended to any other class. The functionality of the final class should be with only that class, further it can't be extended. So you are ending here the object, the inheritance here. We are going to just stop the inheritance here. Like this we can actually use the final keyword. Final we can use with the methods, we can use with the classes, we can use with the property fields. So with the properties or with fields we use it, with the classes we are using, with the methods also we are using. A final field cannot be modifiable. A final method cannot be overridden. A final class cannot be inherited. So like this, we have written here final class, a final method, and other thing is what here, a final field. And similarly, we use the finally with the try-catch blocks. There should not be any confusion between the finally and final. Final purpose is different. Finally purpose is different. Final meaning is you can use a final keyword with a property. In such cases, that becomes a constant. You can use it with a method. The method cannot be overridden in the child class. Similarly, you can use final with the classes. In such cases, a class cannot be using some final class features. That means here, when I try to create extra point by using the features of color point will not be inherited into the extra point there. So like this, we can use the finally block. We can use here finally block with the help of not finally, with the help of final. We make a class, a sealed class kind of thing. Further, you can't use the class to inherit into another class. A final method cannot be overridden in the child class. A final field cannot be modifiable. Once you assign value, that can't be changed. So like that, we have used a final variable. Final variable where we are using with the point class here. Okay, now let me use this final point class here. Come to this point and try to print here. Object P equal to object 3D we have written. Now let me print here the creation time for it. But for printing creation time, you require some format there. So for that purpose, simple date format we can use. Simple date format, it is here SFD, SDF is equal to new simple date format. So using simple date format, we specify only hours, minutes and seconds, HH, then colon, colon, SS, like this we can take and we can print it. We can be printing it. Okay, let us import that. We have imported. Now we created it. At what time exactly object P is created? Try to find out. So object P is nothing but here object 3D, that is right now. So at what time it's created? Let us try to find. Here write system.out.println. Right here point got created at followed by here SDF dot. What method we use? Format we can use in this. So what is the date exactly we use now in this? Here this is going to be object P, then dot, here creation date time we can get. This final field, but get creation date time. With the help of this, it can be printed because get creation date time can give you date object. So it can give you here creation date and time. Try to print here this. Point got created 9:23:43. It's giving message like that. It's giving the message. Point got created 9:23:43. So like that, here we are getting exactly the at what time point is created. Now let us look into the upcasting and downcasting features. Here I create something like this color point. I create here color point. So CP equal to, here it is new color point I put. New color point like this I can set. So here I use color as color dot followed by red I try to use here. A red color I am trying to use in this. Try to set this as here red, a red color trying to make in this. Now let me print here. This is system.out.println. So point created, point got created, point color is color is here plus CP dot. So what we use exactly in this point color we take here. Point color, this is I think get point color dot get color, then dot in this get color, it's giving you color object for us. Can give you color object, therefore write here dot toString. We can use this as here toString. So we print here the color object. Color is what exactly? Red color. It has to print for us red color. Okay, let us print first of all this. Point color is here java.awt.color r equal to 255, g is 0, b is 0 is giving. So it's giving you RGB format. Red component is 255, green component is 0, blue component is 0. There is nothing but red color only. So get color, here we get color here dot. Do we have any name for this? Let us see in this. So it's giving that kind of message for us. Let us try to decode this. Red color is giving like this. We have taken here color dot. It should be returning the string value for us. Should return string value for us. It's not printing any string value for us in that. You have get color space only. Get color space is giving you color. Okay, color components are getting printed here. So nowhere you get the color exactly. Color value we are not getting in this. ToString will be used even in such case also. We are not getting. We are just getting only color component from that. Get transparency, get RGB. So get red, get green, get blue, get alpha. So like this, it's not giving. So we need to override this one. We can override this in this. We can get color component. So individually, one per color can be printed. That we need to write normally. So with the help of this get color, it's just printing the color only. Let us take color and see what it prints otherwise simply. So run as, still it's giving us only r equal to 255, g equal to 0 and d equal to 0. It's not printing the color of the, the color, it's not printing some red, green, it's not giving. So it's giving you only r component is how much, green is how much, d is how much is shown here for us. Okay, so here what we have done, we created a new class called as color point. Now color point is having some extra features when compared with the normal point. What are the extra features we have in this? One is here. The first one in this is a color component we have. That is only extra thing we have in this. When you look at the color point, extra feature in this is what here? Point color. That is the only feature. Otherwise, we don't have any other thing. Now, with the help of the base class reference variable, try to access it. So let me write here in this point object endpoint. This equal to, I use the existing color point here, CP I use. So when I use CP, if I try to use CP dot now, what shows CP? Creation date and time you get here. Okay. So point color is coming here like this. Equals, you have find length between points. These you are getting. But when you come out from this, okay, don't use CP. Try to use here object endpoint. You use this one, put dot here. It gives creation date time It gives find length between points, find length between points, find length, but nowhere you get any information related to color here. Nowhere you are getting color information in this. Though this is referring the child class, point object endpoint equal to CP we have written. So this is referring color point, but the features of all features of color point are not available here, because reference variable is here what point only. Since it is referring the point object, point class, whatever methods are available in the point class, they only you can use as far as color point is concerned. In the color point, you require features related to color, but here with the point object, I don't want to use. I just want to use whatever features are available in the point, that much I can use here. So I create a reference variable for the point, but I am referring the child class. A reference variable of the base class can refer the child class, but in that process, all the features of child class will not be available to base class reference variable. So when I create like this here, point object endpoint equal to CP. So here I cannot use certain features of the CP there. I cannot use any features of CP in this. Only related to CP I can't use here. But the features common to both point as well as common color point I can use, but I cannot use the features of here, simply the color point. So that's why I could not get the color in this. When I put here obj endpoint, the dot followed, when I put dot here, it's not showing all the color methods there. Get color, you are not getting in this. Creation date time is available. Find length between 2 points is available. Like this, you can get which are part of the point class. They only can be accessed here. You can't access the color component of the color point. So like this here, it is going to be called as upcasting. We have taken here a subclass and we are casting to a superclass. This feature is called as here upcasting. But the reverse if you try to do, it's not possible there. Take here CP equal to, try to assign here object P, it will not allow you. If you try to put like this, it will not allow. Object P is what exactly? Here see, type mismatch, cannot convert from point to color point it is. You can't convert from point to color point because color point contains more features. Therefore, if you take a child class reference variable, you cannot use with the superclass object. If you try to take a child class reference variable, you cannot be using with the superclass. Here this is what exactly superclass. Superclass is what object P is here superclass object. So with the superclass object, you cannot use. Reason, when you instantiate CP, what should happen in that there should be methods declared for the color also. But when you look at the point class, you don't have the color definition. Therefore, it does not support like this. But when you look at this one, point object endpoint equal to CP, in the CP you have features of point, extra features are available. So while creating this point object, there is no problem. It can simply refer all the methods which are available in point. Whatever features are available in color point cannot be definitely accessed, but whatever are available with with the point, since they are available with color point, you can access them. But when you look at color point, what is happening? Some extra features are available in the color point, which are not part of the point. If you try to assign CP equal to object P, it will not allow such things. It's not going to allow such things. So that's why you cannot do, downcasting. You cannot downcast, whereas upcasting you can do here. This feature is called as here upcasting, and this is called as here downcasting. Downcasting is not allowed by default. You need to forcefully do that. For that purpose, you need to make it you must make it as something like this. You must write it as color point. When you put like that, in such cases, you can do it here downcasting. You can downcast, but certain functionality may not be available to you here in this. Let us try to print. So what we print in this system.out.println. What will happen in this cp dot, here we try to write get color. So cp dot get color we try to use in this. What happens, see now in this. It's giving runtime error, see. It's giving runtime error. Like this errors you can get here. So it's giving here runtime error because there is no color associated with object P, it can be giving runtime error. So therefore normally it should not be here downcasting. If you downcast, what happens? The color component is not available for object P, it can give error. Time being, if you put like this, but truncation of data is taking place. If you want to use other features, you can use without any problem. So cp dot Now suppose you want to find out get x. You can find out get x. There is no runtime error in such cases. Okay, we have used 0.3D, correct. That is okay. It should not be 0.3D. Therefore, I changed here. Okay. Once again, what I do, object P equal to, before this I use, try to put here, object P is equal to here, new point, make like this, followed by 100, comma 67, make like this. New point I try to make here. Now this time try to run this. It should not give any error in fact. So cp dot try to put the try catch block in this. With try catch, we can be handling it. Or else try to put like this. Cp dot get x. So here catch exception ex. Now let us run this. So it will not print anything this time, because if you try to typecast like this, definitely this can be a problem. Though you set this way, object P, Cp equal to, some of the code blocks are not available with the object P. What is the code block? Get color is not available. So in such cases, the object cannot be totally constructed. So this cannot be functioning proper. I mean, with errors only in the runtime, you get errors. The same errors we are getting. When you use try catch block, nothing may be shown to you, but like this you may be doing. This feature is not normally, this feature is called as here downcasting. Downcasting is not normally supported in this. So Cp equal to color point objp, when you take, what is happening? It's unable to access the full point class in this, because this is a color point and this one is a, I mean, which method this is exactly? This is a point method. In the point method, you have only few features when compared to the color point. So color point reference variable tries to match all the available features of color point. So since some of them are not available, it can't work with that. Therefore, it tries to give us a runtime error there. It's giving runtime error. Since we kept in the try catch block without doing anything, it's just coming out from the code here. If you put any kind of error message, it can show there. Ex dot, you can put it, print stack trace. With the help of that, what is the problem exactly? You can find. It prints here. So it's saying like this here. You can give message in this manner for us. Point cannot be cast to color point. At point manipulation dot main, it's giving error like this. So class cast exception you are getting in this. Since some of the features of the color point are not part of the here point object, you cannot do like that. But you take a color point, you can refer the, I mean, using actually the point object, you can be referring the color point, using point reference variable, you can refer the color point object. But using a color point reference variable, we can't access here the point object, because some of the color point features we can't find with the point, therefore it gives error. Since it's going to give error, so it cannot be working properly, it gives runtime exception. So these two features are called as upcasting as well as downcasting. Downcasting is not allowed, but upcasting is allowed like this. Even previously we saw with the primitive data, so narrowing conversion, widening conversion, we had two things. Narrowing conversion is not allowed, but widening conversion is allowed. So upcasting is similar to widening conversion. Narrowing conversion is nothing but here downcasting. So if you try to do with downcasting, it gives error. It's called as here runtime error. You can't do like this here. So we created a final method, a final variable, a final class, and sometimes we use, I think, even finally also. So like this final we can use with the classes. This is what simple inheritance we have seen in this. We created point class. From point we come to the color point 3D. Then parallel to that we create one more class, color point. So some extra features we added with the color point. Then we have even overridden there. Few methods are overridden. Okay, even toString, which is part of the object class, that also was overridden. And apart from that, we had overloading also. To find distance between the 2 points, we used overloading. So like this, here you can have the classification hierarchy, and here you have total inheritance. From point we are coming to color point. Similarly, we are coming into point 3D. We get like this. So what is happening with this? You are forming the information, this inheritance hierarchy here. Classification hierarchy, we say this is called as here a kind of. A color point is a kind of point. A point 3D is also kind of point. Like this, you can establish relationship between the two, and whatever features are available with point, they are available with the rest of the two classes. So, but certain features of point 3D are not available with color point, because color point is going to be 2D only. Extra color is available to you. But when you take point 3D, you don't have any color component in that. But there, the point features are common. You have third dimension called as Z dimension in that. So like this, we created here two child classes for the point, and here this is called as inheritance. It's called as actually inheritance. So like this, here we created a classification hierarchy or inheritance hierarchy we created like this. So in this we are using the reusability point class as it is we are using with the child classes. Then other thing is we have seen overriding, and we have seen here overloading also. Overloading with what exactly? Overloading we use it with the within the point class we use it overloading. With overloading, first of all, constructor overloading. Second thing is here finding length between the 2 points. To find length between 2 points, we have overloaded this. We have overloaded this particular thing. This feature is called as here overloading. And Java does not support operator overloading. Only you can do method overloading. You can just method overload. But another feature here in this we used is overriding. This is what public string toString, this we have overridden. ToString is part of the object class. That method we have overridden in this. ToString we are overriding in the point, which class it is? Point 2D class. Sorry, in the point class we have overridden this. So overridden part is available with, even with the other class, that is point 3D. In the point 3D, once again we have overridden, that is here Z coordinate we are putting. So this way we can do overriding. Overloading and overriding are the two features with which we can do polymorphic things. Overriding is also polymorphism, overloading is also polymorphism. Overloading is here early binding or compile time binding, we say static binding also. In the case of overriding, dynamic binding, that is lazy binding, as well as late binding also we say. Even we can say runtime binding. So in the runtime, the methods are going to be bounded. Like that, we use overloading as well as overriding features. Any questions on this? Uday, you have any questions?
No, Sridhar.
Tihari, you have any questions? Yeah. So,
No, Sridhar.
yes. So tomorrow further we are going to work with the concept called as interfaces. Geometry class we create. From geometry further we can create a circle class, a rectangle class, a square class. There we can go with the multi-level inheritance. Here we have only first level and second level. From point we are coming into, say here, a point 3D or color point. But in the case of geometry, we create a base class, geometry class, which is abstract, whose object you cannot create. But when you take the geometry class, from the existing geometry abstract class, we can create there a new class called a circle, because geometry is a closed figure. Geometry does not have any fields. When you have a geometry class, in the geometry, with geometry there should be associate methods. One is area, other one is perimeter. Every geometry should have some area, should have perimeter. But simply when you say geometry, you cannot find an area, you can't find any perimeter. Geometry meaning is what? Which closed figure it is? Is it circle? Is it square? Is it rectangle? You don't have an idea. So therefore, you cannot find. Such classes can be called as abstract classes. Similarly, when you work with Windows, what happens? We hear a word called as document. Often we hear word document. So when I ask you to save a document, how to save the document? What document you ask? So therefore, document is what? It is going to contain data. You can come to some sort of conclusion. It contains data that has to be saved, that has to be opened, that has to be printed. But saving changes from one type of document to another type of document. You take Word gets saved in one way. Excel gets saved in the other way. PowerPoint gets saved in the other way. If it is PDF, in the other way it gets saved. So, like this, documents changing and saving can be changing from one document type to another document. But after all, they are all what exactly? The documents only. That means every document must be having provision for saving, opening, then printing. Then like that, you should be having provisions. So therefore, document can be called as a base class, which is nothing but abstract. So save also, you can't write any code for that, because how you save, what is the data structure for saving data, that is important. If you take Word document, it has certain structure which is proprietary, we don't know anything about it. Similarly, you take Excel got some proprietary, we don't know anything about the Excel structure also internally. When you take PowerPoint, it also has got some structure, we don't know much about it. So like that, they have their own structures. So depending on the type of file, you have to save using that particular structure. Therefore, here the methods, when you say save method, save as method, open method, print method, they are all going to be abstract. We cannot give any definition there. But same document, when you take and put into a PDF or into Word or into Excel or into PowerPoint, they are more clear, you get clarity. As per the structure of the documents, you can be saving it. So therefore, here Word document is actually meaningful document, Excel document is meaningful, PowerPoint is going to be meaningful. So simply when you say document, there is no meaning. Such classes are called as abstract classes. We have abstract classes. So those classes, further we need to extend into subclasses, child classes. You have to override them within the child classes. So we discuss tomorrow about the classes like this. We may use a concept called as graphics, or we may use a concept called as geometry, or we may use some document concept. With that we can do it. A document you can save as an XML document, like a PDF document you can save. So in different formats you can be saving it. So that we discuss tomorrow. If possible, just try to go through the abstract classes, abstract methods. So similarly, virtual methods, what they are exactly, just try to go through. There is nothing like virtual in the Java, but here whatever method, if you can override, if you want to override, you can override, otherwise you can leave it, just like toString. So toString can be called as here virtual. If you want to override, you can override, otherwise you can use the existing features. Such methods normally called as virtual methods. We don't mark anything like virtual in such cases. Okay, so tomorrow we meet. With those concepts, we work tomorrow.